We will be asked to find averages of normal distribution. What do I mean by that? Let's say you have a X distribution where X is a normal distribution. They are going to give you like n different kinds of X. You have X1 to Xn, which are different samples of X. Okay, you can call this as samples, or another word for this is also things like instances. But basically, they all are generated from X. Okay, I give you a little bit more understanding on this first. What it means is if you have X1, X1 is still mu sigma square. There's no change in the distribution. They take from X. So X2 also the same, still mu sigma square. So you can think of it like different objects, all from X. We will be asked for this thing called X bar. Okay, when you read this, it's read as X bar. So what is this X bar? Okay, in more layman, this is the average or the mean of n samples of X. You have n different X and you want to check the average distribution. We will need to learn how to apply the formula, although I will also show you the proof. There are two important things here. If you observe the distribution versus X, you will notice that the mean stays the same. Same mean. You don't divide by n or times n, nothing. It's exactly the same. But the variance is not the same. You must divide by n at variance. If initially it was sigma squared, now it's sigma squared over n for X bar. Okay, but we try to prove together. So we're going to start with X distribution. It's mu sigma squared. Now let's write down what will happen to the sum. We do it slowly. Let's deal with the numerator. So I want to have x1 plus x2 all the way to xn. When you add up n different objects, what do we know about the mean and variance? You will times n to both. We don't square the n. Subscripts don't square. This n exactly goes to the variance, same number. Don't square this value if it's a subscript. Different object subscript, you multiply by n. But you now need to multiply as a coefficient of 1 over n. We are going to view this division as a multiplication by a coefficient. Okay, which means over here we will have x1, x2, all the way to your xn. This will follow a normal distribution. What happens to the mean and variance? Mean divided by n. Variance is now n squared. So why is it so? Again, this is a coefficient. Coefficient you must square when you apply it to your variance. So we simplify the whole distribution. On the left side, this representation of average is written with a line at the top, got x bar. We read it as x bar. So x bar follows normal distribution. Left-hand side is mu. Right-hand side, now we get sigma squared over n. So it is over n actually because you multiply n first, but we divide n squared. So it ends up with divide by n. Okay, so when should we use this? You want to use x bar when we have average of the same object. Or let me write as same variable x. If they ask for the average and all of them are the same variable, you directly apply the formula. Okay, so let me show you what I mean by this line in the context of our question right below. We have got two kinds of mass here. You have got girls and boys. They are normal distributions. The mean and SDs are already stated in the table here. So part one, can we get the average? And if you look at the next phrase is average of 10 objects. You want to have two kinds of phrases, average coming first, and then average of n objects. Average of n objects, it will then mean that you are looking for x bar. Okay, and you want this to be less than 51 kg. Okay, so when we start the problem, I have defined your G and B. Can we write down the respective distributions? G will be 47, 5 square. My B is normal 53 and 4 square. We are looking for average of that 10 objects. So we are looking for B bar. B bar by itself doesn't tell you how many. So to be exact and so that you don't forget later on, you can write in how many Bs you were doing for. I'm doing average of 10 objects, so I will write down B1 to B10. Now these are all the same objects. I'm doing average all on Bs. So I could directly apply the formula seen above. Mean stays exactly the same. Variance divide by n. Okay, then you can calculate. I want B bar to be less than 51 kg. Again, this is your normal CTF. I will skip that GC step. You can use the graphing calculator normal CTF to get this number. Okay, part two. You again have the word average. Okay, but remember, I just remind you one more time, they can also use the word mean. Same thing. Average of what? You should see number of objects coming later. Average of 3 girls, 7 boys. So you have average of a certain number. But are they the same object? Girls and boys, these are different variables. So you are looking for average of different objects, which means that you cannot be applying the formula we talked about above. Only same object, you can use that formula. Okay, so we should define something else. I can say, can we let T be? Let's write down what average they are looking for. You want G1 to G3, 3 girls. And I want 7 boys. So we go for B1 to B7 for your 7 boys. Total 10 objects. So you divide by 10 throughout. You want to get the new expectation and variance. When you see a division, you should treat it as a coefficient outside. Just think of it as you're multiplying 1 over 10. So you've got 3 different G's and 7 different boys. Variance, similar. Just that you have to be careful once again. The 1 over 10 is a coefficient, so you want to treat as 1 over 10 squared. And you have 3 times variance, 7 times variance. Do not square the 3 and 7, they are subscripts. Only coefficients we square. And we should write down the distribution. So 51.2, 1.87. We can have probability T. Question is looking for less than 51 kg.